Today I'm going to go over different Unit 4, Lesson 5 independent practice problems. Let's go ahead and jump in. This tells us that point P is the intercenter of triangle RST. So point P is my intercenter. Given this information, what can I conclude? Well, I know when I have an intercenter, my concurrency of angle bisectors of a theorem tells me that all of my sides are equidistant from my point of concurrency, which means that this is congruent to this, which is congruent to this. Given all that information, what can I conclude? So let's see. CP is congruent to RP. CP is congruent to RP. Well, as we can see, those two lines are congruent. Instead, PC, or I'll do the way it goes, CP is equal to or congruent to AP, which is congruent to BP. So that doesn't include RP, so we can go ahead and cancel that one out. CP, or BP, is congruent to BC, or CP. Well, that's something that I concluded from here, right? BP is congruent to CP. So I can go ahead and select that answer. But let's look at the other answer choices just to be sure. The measure of PSC is congruent to the measure of PTC. Well, that's not something I can conclude directly from my theorem. So that won't be an answer choice. Can I conclude that BPS is congruent to APT? Oh no, that's not something I can conclude from my congruency of an angle bisector theorem of a triangle, so B will be my answer. Let's look at the next problem. This problem states point H is the circumcenter of triangle JKL. So point H is my circumcenter. What can I conclude from that? Well, remember that my concurrency of a perpendicular bisector of a triangle theorem told me that my circumcenter is equidistant from each vertex. So that means that this would be congruent to this, which would be congruent to this. Or JH is congruent to LH, which is congruent to KH. That's what I can conclude from my concurrency of a perpendicular bisector of a triangle theorem. So I want to look for something that displays this in my answer choice. FH is congruent to DH. Well, that's not something I can conclude just from looking, or just from accounting for my concurrency of a perpendicular bisector theorem. So I can cross that out. JF is congruent to JD. Well, again, this isn't something I can conclude just based on my concurrency of a perpendicular bisector theorem. JH is congruent to LH. Well, as I see here, I did in fact identify that JH is congruent to LH, so I can select that answer, but let's look at the last one just to be sure. KF is congruent to LD. Again, this isn't something I can just simply conclude from my perpendicular, or my concurrency of a perpendicular bisector of a triangle theorem, so I can mark that one out. Let's move on. This problem states point G is the incenter of the triangle. So basically, point G is the incenter, which is located equidistant from each side of the triangle. Okay? And now we're going to look at angle bisectors. So here we're given an angle bisector GF, which bisects our angle F, which is located here, thus breaking F into two congruent halves. So given that information, we're being asked what is the value of X? Well, the easiest way to go about this is to solve for X. If we know that F has been broken into two congruent halves, we can go ahead and do 16 equals 2x. I need to isolate my x, so I'll divide by 2. And thus I get x is equal to 8. And thus B is my answer choice. let's go ahead and look at the next problem. This says point A is the circumcenter of DEF, which basically tells us that our point of concurrency is equidistance from all sides of the triangle because we have an incenter. And therefore, we're being asked, what is the length of NA? Well, in order to find the length of NA, what we could do is find the lengths of either of the other two congruent sides because NA is congruent to LA, which is also congruent to MA. And we know the measures for LA and MA, but we need to solve for X in order to find the exact measures or exact units of those two congruent segments. So we'll do fx minus 1 is equal to 6x minus 3. And I'm going to go ahead and move my 3, which gives me 5x plus 2 equals 6x. Gonna move my 5x, which gives me x is equal to 2. Now I know as x is equal to 2, I can go ahead and plug into either of these two functions because all the segments LA and MA are both congruent to NA, so I only need to do one. So I'll do LA. LA is equal to 5x minus 1. I'll go ahead and substitute my value for x. So 2 minus 1, which is LA is equal to 10 minus 1, which gives me LA is equal to 9. Therefore, NA is equal to 9, LA is equal to 9, and MA is equal to 9. So my answer choice is B, 9. Let's go ahead and move on to the next problem. This problem states the point of concurrency of the angle bisector of DEF. So point A is the point of concurrency, or the incenter of the angle bisector of triangle DEF. So that means that my point of concurrency is equidistant from all of my sides, showing me what is congruent. So YA is congruent to ZA, which is congruent to XA. And then I'm being asked, what is the length of ZA? Well, I know that ZA is equal to XA and YA, and I am given that XA is equal to 3, which means that ZA is also equal to 3, which means that YA is also equal to 3. So my answer is A, 3. Let's look at our last example. This says point X is the circumcenter of triangle ABC. So X is the circumcenter, which means that the point of concurrency is equidistant from all the vertices in this instance because we have a circumcenter. Okay, so that tells us that AX is congruent to BX, which is congruent to CX. And then it asks, what is the length of MB? Well, the concurrency of the perpendicular bisector of a triangle theorem also tells us that we have perpendicular bisectors which cut each of the sides into congruent halves. So AB is also equal to MB. BN is also congruent to NC. And CL is also congruent to AL. All the things we learned from the concurrency of a perpendicular bisector of a triangle theorem. So when we're looking for the length of MB, we need to find the length of AB. Or AM rather, sorry, that was my mistake. AM. So AM is equal to MB, BN is equal to NC, and CL is equal to AL. Yep, okay. So when we're looking for the length of MB, all I have to do is see if I have something for AM, and I do. I'm told that AM is equal to 2.5 centimeters, so that means if AM is equal to MB, then MB is also equal to 2.5. So therefore, C is my answer. I hope this was helpful. If you have any questions, please do not hesitate to reach out.